Before we hop into relativity, let's address the interesting question of what, in fact, is the speed of light. For a long time, people knew light moves really, really fast. So fast that for a while we couldn't tell whether it had a speed at all, or if it really moved instantaneously. It was in fact in the late 1600s, way before relativity, that people first measured that the speed of light was finite. An astronomer by the name of Ole Romer looked at the period of the orbit of Jupiter's innermost moon and discovered a peculiar difference when observing this period during part of the year that the Earth was moving around the Sun towards Jupiter versus when the Earth was moving away from Jupiter. They measured this by timing how long it would take for the moon of Jupiter to reappear once it has disappeared behind Jupiter in an eclipse that happens every orbital period. So this is Jupiter. And this moon here that you could see, when it passes behind Jupiter, it disappears for an amount of time that you can measure. And when it appears again on the other side, you can get an estimate for the period of this moon's orbit. But what we really care about is how long between when the moon disappears and when the moon appears again. It turns out that the moon appeared a few minutes faster when the Earth was traveling towards Jupiter than when moving away. Let's see if we can understand this. So here's the Sun. This is Earth's orbit around the Sun. And we'll say that Jupiter is right here, fixed. This is not drawn to scale. So in the time that it takes Earth to go from here to here, Jupiter's moon disappears behind Jupiter and appears on this side. And the difference versus when the Earth, let's say when Jupiter's moon disappears here and the Earth is moving away from Jupiter, and when the moon reappears, the Earth is now over here. So if light is moving with a finite speed, it has to travel this much less distance when Earth is moving towards Jupiter once the moon has reappeared on the other side. So the period will be less by this distance divided by the speed of light in terms of time. Likewise, when the Earth is moving away from Jupiter when the moon disappears, light will have to travel this much more distance in order to reach the observers again. And so the time of the period will appear more by this amount of time. So the distance the Earth has traveled in that time divided by the speed of light. So this will add to the period and this will subtract from the period. And this is exactly what astronomers observed in the 1600s. They saw that these two periods were different by some small amount, and they used that small amount to estimate the speed of light. Note that if light travels with infinite speed, there would be no difference in how far the Earth travels, because light would get there instantaneously. So we have observed that light has a fixed, finite speed, which is incredibly fast, over 200 years before Einstein was born.